Okay, picking up from where we left off last time, we're on number 30, and like I mentioned in the others, the ideas just seem to be hopping around, so don't think that it's progressing in the same order that we progressed during the course. So you just got to be prepared for anything, basically, is how it works out. Um, so this one says divide. Now, it's very important that you look and see what in the world you're dividing by. So make sure you look at this. That is a monomial. That is all one term. There's no addition or subtraction in it. So that actually makes this the easy kind. Easy in the fact that you can break it up and work it. So what I would suggest is that you write it, since this is a monomial, write it as a huge fraction. So you have negative 9u to the third y squared plus 10 u to the 6th y to the 6th plus 18 u squared y. All right. Now in the bottom you have negative 2 u to the third y squared. Okay, because that's all we did was rewrite the way the division problem was set up. They had it horizontal, we turned it into vertical. Now what this means is every term in the top, and we have a plus sign here and we have a plus sign here. So that means we have 1, 2, 3 terms. Each one of those is divided by this same denominator. So break up your problem. So we have that piece is over negative 2 u cubed y to the second plus, and then we've got 10 u to the 6th y to the 6th over negative 2 u cubed y to the second plus 18 u squared y. It's just a lot of repetitiveness. Just write it all out. And once you do that, then you can cancel, or simplify is a better word. Cancel is not good. Simplify or reduce is a better terminology for it. And it says simplify your answer as much as possible. Okay, well on the first term, just look here. Focus there and just disregard the other part right now. We want to simplify. Well, our negatives cancel. And 9 over 2. I can't do anything with 9 over 2, so I'm just going to have to leave it. It's a 9 in the top and 2 in the bottom. Now when I look at my u's, so you do each variable individually. I have u to the 3 in the top, u to the 3 in the bottom. So since my powers are the same, those simplify. You have no u's in your solution. Same thing with the y's. The powers are the same, so those simplify or reduce. You don't have any in your answer. So in all honesty, I need to shorten up the little fraction bar there. There we go. So let's go to the next guy. I have 10 divided by negative 2. So that means these two signs, since they are different, I need to connect with a minus sign. So because 10 divided by negative 2 is going to be a negative 5. All right, now that would be in the top of my fraction. So if you wanted to do the fraction, you could. But as we progress, you'll realize we don't need it. Because when you look at your u's, there's 6 in top, 3 in bottom. Well, you're going to subtract and put, so that 6 minus 3 is 3. I'm going to put that where the larger exponent is. That's up top, so that's u to the third up top. Go to the y's. Well, I got 6 up top and 2 in bottom. Subtract, that's 4. So there's 4 left over, again, in the top where the larger power is. So that's the reason you really don't need the fraction bar. There's no need to write it as a fraction, so you can just kind of bump that out. We're good with that. Now scoot over and look at your third fraction. We have 18 divided by negative 2 is a negative 9. Now if you want to set it up as a fraction, go right ahead. We have u to the second over u to the third. Well, they're on different levels, so we are going to subtract, and 3 minus 2 is 1. But this time, my big power is in the bottom. So put u in the bottom. And then that power is an understood 1 for your y. Again, we're going to subtract them because we're on different levels. And 2 minus 1 is 1. The big power happens to be in the bottom again. So that right there in the black, even though I kind of ran into some of the other stuff, that's my simplified answer. That's as good as I can get right there. We have divided, we have simplified. Okay, go to the next one. It does say divide. The first thing you want to do is look and see what are you dividing by. Oh my, they gave us a binomial. Okay, since you're dividing by the binomial, you actually have to go through and do long division. Yes, this is the hard stuff. So this is where you set it up and you put the house, the divisor, one that you're dividing by, goes outside, and then inside the house, you're putting what you're actually dividing. So so this becomes the little part in here. Just copy it down. Make sure you don't have any skips in your powers. So we have an x squared, we have an x to the first, and we have a constant, so there's no holes or gaps that we need to fill. So remember, we want to keep it very structured and very neat. So ask yourself, what do you multiply 3x by to turn it into 15x squared? Well, that would end up being 5x, so I need to put it in the x column. So that's the reason I put it there, is because my powers match. Now I'm going to multiply 5x times this. Now the way we had done it in class is that we had said, just to kind of keep our head straight, we're going to write it down over here, 5x times 3x plus 6. Now let's write that down and put it right here. So 5x times 3x is 15x squared. 5x times 6 is 30x. Now the next step is to subtract, which means we have to change our signs and add. So I'm going to go in here and I'm going to change all my signs. So I'm going to change it. I'm going to circle what the new sign is. Now I'm going to add the two lines. Remember, the first column should always disappear. In the second column, you need something. So we're hoping it does not disappear. We got 42 minus 30 gives me 12x. I've completed one whole cycle. I just need to drop the 24. Now I'm ready to start again. So start over. Look at your 3x. Look at your 12x. What do you multiply 3x by to turn it into 12x? Well, that would be a plus 4. So we're going to take 4 and we're going to multiply it times 3x plus 6. So that's going to give me 12x plus 24. All right. What we had done before is we're going to change the signs. And then we're going to add them together. And that goes away and we get a remainder of 0. So when it asks you over here for quotient, quotient is this part up at the top. 5x plus 4. Remainder that we got was 0. So we're done. Okay, let's go on to the next one. Factor by grouping. So that means let's put two of them together and see what we get. Just start somewhere. If it doesn't work out, then back up and try a different pairing. So let's see here. If we've got these two, I can't do anything with the numbers because 5 and 4 are not similar. There's nothing in common. But they all have x's, so I can take 2 x's from each term. That leaves 5x, and then when I take x squared from the last one, I get 4. Okay, now I'm hoping that whenever I go to the second two and I pull out what's common, I'm left with 5x plus 4. That's what I'm shooting for. So let's see here. I've got 25x and I've got a 20. I know 5 goes into both of those. When I take out 5, 25 divided by 5 is 5x. 20 divided by 5 is 4. Well, did I succeed? Are my groups the same? Yes, they are. So that lets me know I'm good. Let me keep going to the next level. Well, that means I'm going to factor out the group. So this is coming out of that the second term. This is coming out of the first one. So I'm writing down 5x plus 4. And that leaves me the front part and this front part. So just write it together, and you've got it factored by grouping. Okay, move on to the next one. This one is z squared plus 5z plus 4. It's a trinomial. There's nothing in common. There's no, you can't take a number from the first term. You can't take a letter from the second. And since it's a trinomial, hopefully you're thinking go to 2 binomials. Is it easy or hard? Well, when you look up front, there's a 1 in front of z squared. So that means he's easy. So we just need z and z. Now read it from the back. What two numbers multiply to 4 and add to give you 5? Well, that'd be 4 and 1. Signs are the same, both plus. It's factored. Okay, keep going. It says, can the distributive property be used to rewrite 8 times 5 plus 7? Okay, now this actually goes into, in all honesty, I don't remember talking about this, but what this, it must have been like the first week or two. It goes back to, do you know the full name of the distributive property? This is what it's called. It is the property of distribution, I almost forgot it myself, of multiplication over addition. So what's happening is you're distributing by multiplying, but you're having to do it to a group that is either added or subtracted. You can't do it to a group that is multiplied or divided, is the point. So when you look at this, I am saying 8 times a group. Well, that's 5 plus 7. So that would work for addition. And this is multiplication. So this should work like a charm. So I can say 8 times 5. So 8 times 5. And then 8 times 7. And it works beautifully. Not a problem. Okay, so this one says, can the distributive property be used to rewrite this? Well, according to what I just wrote on the other page, you want to look in here and see, is this addition or subtraction? No, it is not. It's multiplication. It is not the distributive property of multiplication over multiplication. It's multiplication over addition. So this is a big fat no. You can't do that. Okay, so can the distributive property be used to rewrite this? Did I just recopy that problem? I feel like I'm duplicating. It basically is the same thing. You've got multiplication over addition, so this is fine. And you would just distribute 5 times 7 and then 5 times 8. So, not a problem. And once again, distributive property. Can you do multiplication over division? No, that's not the name of it. It's multiplication over addition, which you could swap out for subtraction, but not multiplying and dividing. So this is a big fat no. Okay, so we finally get on to something else. Solve for x. Well, I'm assuming most of y'all said, ew, fractions. So we want to go through there and we want to clear the fractions. What you need is a least common denominator. Okay, so I would say we've got 3 and 2. Well, that's got to be 6, right? Well, 6 and 7 don't have anything in common, so you're just going to have to say 6 times 7. Well, 6 times 7 is 42. So we're going to multiply everything times 42. So 42 times 4 thirds minus 42 times 5 half x equals 42 times negative 9 sevenths. Okay. Now, you can use your calculator here, so you do not have to do this in your head. Calculator will work just fine. Let's see here, 42 divided by 3 is 14. 14 times 4 is 56. So if you just did the whole thing, it would just tell you that answer. So 42 cut in half is 21 times 5 is 105. Don't forget your x, rather important. 7 goes into 42 6 times, and 6 times 9 is 54, but don't forget your negative. So we're solving for x. I'm going to bring that down. Oops, I forgot to show my work. Subtract 56 on both sides. All right, my signs are the same, so I'm going to add the two numbers. That would be, 54 plus 56. Oops, I had something in there. 54 plus 56 is 110. And it is negative because I'm going to keep the same sign. So if I divide both sides by 105, this is rather odd. We're just going to need to reduce that fraction. So you can do your second PRB, enter. And let's see here, 110 divided by 105, because the negatives cancel, right? Second PRB, enter. Second ABC, enter. Okay, that show didn't work. Let me try that one more time. 110 divided by, I think I hit multiply, 105. And then I'm going to hit second PRB, enter, and second ABC, enter. There we go. 22 over 21 is what I get. All right, we'll continue in the next video.